welcome to your fourth video. In this video, we're going to be talking about Chapter 1, Lesson 4, the distribution property. Our objective is we're going to use distribution to solve problems. So evaluate, again, just means to solve. We're going to use distribution to simplify expressions as well. Two standards that we're going to be addressing is Algebra Standard SSE 1B still, and Algebra Standard SSE 2. Let's go ahead and get started on this lesson today. For our vocab today, we got 3 vocab words that we're going to be going over. We're going to go over like term, simplest form, and coefficient. Go ahead, pause the video, make sure you get these definitions down in your notebook. I'll be covering them first thing when we go over them. Like terms. They are terms that contain the same variable. So in order to be a like term, they have to have the exact same variable. Or they are corresponding variables that have the same exponent. So if the variables are the same but the exponents are different, they're not like terms. But if the variables are the same and their exponents are the same, they are like terms, and you can put those together. Simplest form is when we have all like terms combined. And anything that can be solved is solved. So you want to make sure that you have everything that is able to be solved in the problem done. Or if you have a fraction, make sure you simplify it down into its lowest possible terms. And then that would be simplest form. A coefficient is the number in front of a variable. It's the number that's actually multiplying to the variable. So a number in front of a variable, which is right next to it with no sign in between, is actually multiplying. Make sure you remember that rule. We're going to be using that a lot this year. Next slide, we're going to have the definition of the distribution property. And I'm going to be using the distribution property all throughout this lesson because this entire lesson is called the distribution property. So make sure you get the rules of distribution property. We're going to be covering that all throughout the lesson. Let's get going on today's lesson. For this slide, we have our key concept. Our key concept is the main thing we're going to be going over in this lesson. We're going to be talking about the distribution property all throughout this lesson. Make sure you copy everything that you see on the board. I'm going to kind of talk about it as you guys are copying it down. So the key concept is distribution property. And the distribution property really kind of means this. It means the number that we have outside parentheses is actually going to multiply to every number inside the parentheses. And I did underline the word every number because sometimes we have more than 2 numbers inside parentheses. And we need to make sure that the number that's outside goes to every single one inside. So in algebra, it kind of looks like this. If I had A times the quantity B plus C, what happens is this A that's on the outside is going to multiply to B, and it's going to multiply to C. Well, A times B is AB. A times C is AC. Now, it doesn't matter if that A, if it's on the left side or the right side, it still does the same thing. If I started with the quantity B plus C times A, since the A is next to parentheses, that means it's multiplying, we could take this A times B and A times C. And it still gives me AB, because that's A times B, and AC, because that's A times C. Subtraction works the same way. One of the things that you do want to make sure, though, is that you never change the order, because when you do subtraction, it matters. The commutative property doesn't apply to subtraction. So we need to make sure that whenever we're doing problems, if a B came first, a B stays going first. We don't change the order, so that way we don't mess up the problem. So again, you do the same thing. A times B, that's AB. A times C, that's AC. Again, if it's on the right side, it's still not going to change the problem. We still approach it the same way. A times B, that's AB. A times C, that's AC. Notice that the sign that's in between both of these stays every time. The addition sign stays, the subtraction sign stays. So we need to make sure that we keep the sign that's in between them the same, unless the properties say that we have a negative and negative, which means we change it to a positive. Now, how it works in numbers, and I know a lot of you are probably looking at that and you're like, why do I need to do that? Because 3 times 2 plus 5, well, I know that 2 plus 5 is 7, and 3 times 7 is 21. Well, the distribution property just shows that even if you give it to each, you're still going to get the same answer if you do it correctly. So if I took 3 and I multiplied it by 2, that would look like this, 3 times 2. 3 times 2 is 6. If I take 3, multiply it by 5, that looks like 3 times 5, which is 15. And if I add 6 and 15, I get 21. So what the distribution property is showing you is that sometimes if you're doing PEMDAS and you solve inside parentheses, you'll get the same answer as if you do distribution property and take that number that's right next to parentheses and give it to each one if you do it correctly. So here we know that 4 times the quantity 9 minus 7. Well, we know that 9 minus 7 is 2. 4 times 2 is 8. So our goal is to show that we can do distribution and still get the answer of 8. 4 times 9, that's 36. 4 times 7, that's 28. And if I take these two numbers and subtract them like it originally said, 36 minus 28, I'll get 8. So the distribution property does work in addition and it does work in subtraction. What we'll do is we'll show you how to take distribution property and make multiplication a lot easier. I use distribution property when I multiply in my head. I'll show you kind of how I do that later on in this lesson. And we'll see how distribution property will help us when we have variables and we have numbers. Sometimes it's easy to solve inside the parentheses, sometimes it's not going to be easy. So make sure you have this down. I'll cover more how to do distribution property, and I'll even cover why you see that I'm using these arrows, because that'll make it so I know I did that property correctly. Alright, let's get going on to our first example for today. In our first example, we're going to be talking about Juan and him walking 5 days a week. So here it says Juan walks 5 days a week. Each day he walks at a fast rate for 7 minutes and he cools down for 2 minutes. We're going to use the distributive property to write and evaluate, which means write and solve, an expression that determines the total number of minutes that Juan walks each week. So our goal is we have to use distribution. We're not just putting it all together. We're going to actually give to each one, because the word distribute means to give. So we're going to give that number to each one of those numbers that we see in this problem. So we need to talk about what's the thing that we have that's the same and what's the thing we have that's different, so we can figure out what goes on the outside and what goes on the inside. So we know that Juan walks 5 days a week. Each day he walks at a rate for 7 minutes and for 2 minutes. One of the things that you can do when looking at a math problem is you can underline anything that might involve numbers. So 5 days, 7 minutes, 2 minutes. Now I'm looking at this and I see that minutes are the same. So what I'm going to do is I'm going to say, well, I know he's walking for 7 minutes, plus he's walking for an additional 2 minutes. I'm going to go ahead and put this inside parentheses because I know he's doing this for 5 days. 7 minutes of fast walking, 2 minutes of cooling down. So he's doing two different things, but this is how long he's walking between each one, 7 minutes and 2 minutes. We know he's doing it 5 days, so we're going to multiply 7 minutes and 2 minutes by 5 days. Now the good thing about distribution is because we have this number on the outside right next to parentheses, we could say, well, 5 times 9, and that's 45 minutes total. But since the problem says we have to use distribution, we actually have to give that 5 to each one of those numbers on the inside. One of the easiest ways so you don't forget that you did distribution is by using arrows. I'm going to give 5 to 7, so this means 5 times 7. And I'm going to write that. I'm going to give 5 to 2. This means 5 times 2. So what I really have is 5 times 7 plus 5 times 2. Well, 5 times 7 is 35, and 5 times 2 is 10. And if I add 35 plus 10, I end up with 45 minutes. Yeah, I do know that you could have took 5 times 9 and got 45, but now that you distribute it, you actually know that 35 minutes is how much he's walking at a fast pace, where 10 minutes is all of his cool down time. So when you distribute, you're able to tell still the difference between the two. 35 minutes at a fast pace, 10 minutes at a cool down, and 35 and 10 make 45 minutes total. Now in math, if you aren't using the property that it's stated to use, you probably won't get all the points. Yeah, you'll get some of the points with me if you get 45 minutes. Make sure you show the distribution property. Now I can show you the distribution property because I'm using these arrows that says I go to each one. This helps me remind myself if I did or didn't do that problem. So 5 times 7, 5 times 2, the sign in between just comes down. Let's go ahead and do some more problems on distribution property. That's what this entire lesson is about. I hope you understand it by the time you're done. Let's see what we can do. In example 2, we're going to be using the distributive property to rewrite 12 times 82. This is my favorite part because this is actually how I actually do a lot of my math in my head. So I'm going to show you how to actually kind of make multiplication a lot easier by doing distribution property this way. So what we could do is we can look at those two numbers and we say which one would be easier to multiply with to single digits. Well, I think that 12 times 8 is an easy number to multiply with. Now, you could pick the 12, you can pick the 82, but I think multiplying by 12 isn't too bad, and I think I can multiply it by 8, and I can multiply it by 2, so that's good to go. That's what I'm going to do. So what I would do, if I was doing distribution property, is I'd write my original problem. I have 12 times 82. And if I was doing this in my head, I would say what I'm really doing is I'm really doing 12 times 80 plus 2. So what I just did there was I broke apart 82 to make it 80 plus 2. And 80 plus 2 still is 82. So what we're going to do now is we're going to do distribution property to find out the answer. Well, I know that 12 times 8 is 96, and since I have a 0 here, I'm going to add a 0 at the end, so I have 960. Then I know that 12 times 2 is 24. So I really have 12 times 80 and 12 times 2. Now notice I did 12 times 8, got 96, added the 0 because the 0 that's here. 12 times 2, that's 24. Now when we add these together, we'll get 984. So I just figured out what the answer was by doing the distribution property. Now you could have done the distribution property the other way if you wanted to, and instead of breaking apart 82, you could have broke apart 12. I'll show you how that one looks right here. So if I would have put 82 on the outside, that would look like 82 times 10 plus 2, because 10 plus 2 is 12. Now we do the same thing. When we distribute, the number that's on the outside goes to each one on the inside. So since 82 is on the outside, it's going to go to 10. 82 times 10, all we do is add a 0. So it's 820. Drop the sign down. 82 times 2, well, I know that 2 times 80 is 160, and I know 2 times 2 is 4, so this must be 164. Now, I can add these together. 800 plus 100 is 900. 20 plus 64, that's 84. So I get 984 doing it the other way. Now notice I didn't use a calculator to make 12 times 82 happen. What we did was we broke apart the number and multiplied it by something smaller that makes it easier. I think it's easier to do it this way, but you can also do it this way if you think that multiplying by 10 and multiplying by 2 is pretty easy, because when you multiply by 2 you just double the size. So we're able to break apart numbers to make multiplication easier and do distribution property and still get to the same answer. We're going to be practicing this in class. If you have questions, please ask, so that way we can practice more. I really want you guys to get a hang of this distribution property and how it works. Notice that every time I multiply, I show arrows to say this is what I'm multiplying to. It doesn't hurt to actually include those arrows as you're multiplying. In this problem, we're going to be using the distributive property to rewrite 6 times 54. And we're going to approach it in kind of the same manner that we did before. We're going to break apart the number 54 because that's the bigger number, and we're going to leave 6 alone. It's going to be our number that we're going to put on the outside. So we're really going to be taking 6 times 50 plus 4. So what we did was we broke 54 down into its tens and its ones. 50 plus 4 is still 54, but we're going to make it a lot easier to actually multiply by taking this number that's on the outside, making it go to each one on the inside. So I have 6 times 50, plus I have 6 times 4. Well, 6 times 5 is 30, and since 50 has the extra 0, that means this is 300. Plus 6 times 4 is 24. So in this problem, what I really have is 300 plus 24, which equals 324. Now notice I multiplied those numbers pretty fast. I know that 6 times 5 because I know my single digit multiplication. I know that 6 times 5 is 30. Then I just add a 0 because 50 just has a 0 at the end. 6 times 4, that's 24. Put them together, 324. Again, this is how distribution property can make multiplication a lot easier when working with bigger numbers. We break it down to its different digits, and it actually works too when you're dealing with something there in the hundreds. You can break it down into its hundreds, its tens, its ones. If it's in the thousands, you can break it down into the thousands, the hundreds, the tens, and ones. So if you go by each place value and you add zeros and make it work, you can actually do distribution property and get that answer a lot easier without using a calculator. No calculator was needed in this problem. All I did was put things together based on single-digit multiplication. Let's practice some more examples and see what happens. So as I was saying, with single-digit multiplication, this makes it a lot easier if we break apart numbers. So I gave you a problem here that says use distribution property to rewrite 3 times 124. I did already put 124 inside parentheses. I just figured that's what I'm going to do anyway, so let's go ahead and solve this problem using distribution property. So we're going to take 3 times 100 plus 20 plus 4. Notice I took the number 124 and I broke it up into its hundreds, its tens, and its ones. Now we're going to multiply that 3 to each one of those numbers on the inside, because that's what distribution property means. The number on the outside multiplies to each number on the inside. Well, we have 3 times 100 plus we have 3 times 20. And then we have adding 3 times 4. So 3 times 124. 3 times 100 is 300. 3 times 20 is 60. And 3 times 4 is 12. So if I had 3 times 124, I'd have 300 plus 60 plus 12, which equals 372. Pretty cool, huh? In example 5, we're going to figure out one of the main reasons why we actually do the distributive property. And this one is because it's adding variables. In this problem, it says that we see y plus 3 12 times. So if I saw y plus 3 12 times, it would look like this. Y plus 3, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, not many of us want to write something out 12 times to get the final answer. But if we look at this, we could count how many times did y come up. Y came up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 letter y's. Then I could say, well, how many times did 3 come up? Well, I have 3, 6, because I'm adding them together, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. So I really have 12 y's plus 36. And this is what we're actually doing when we do distribution property. But instead of writing it out 12 times, we're just saying we're going to take that 12 on the outside and it's going to multiply to each one on the inside. It's going to make things a lot easier instead of writing something many times to get to that answer. Sometimes the number could be even bigger than 12. It could be 156. And there ain't no way that I want to write something 156 times and then figure out how many I have total. So what we're going to do is we're going to do distribution property. We take the number that's on the outside, and we're going to multiply it to each number on the inside. So I have 12 times y. I'm going to write 12 times y. Plus, we have 12 times 3. So we're going to get to that answer a lot quicker than writing something 12 times. Well, if I have 12 times y, that means I have y 12 times. Well, if I have y 12 times, I really have 12 y's. 12 times 3, that's 36. We get to the same answer that we got over here by writing it out 12 times, but we didn't have to count it, we didn't have to put it all together, we were able to do it just by doing multiplication and distributing it to each one. So from now on, I'm going to use the distributive property and not write it out that many times, but know that what this really means is that you see the y plus 3 12 times, you add it all up and you get the same total. So we use distributive property to make things easier, especially when it comes to variables, because sometimes we can't always put the numbers on the inside together right away, and we actually have to give it to each one. In example 6, we're going to be distributing with something that has 3 numbers on the inside in this case. There's y to the second power, 8y, and 2. So there's 3 terms in that problem that we're going to be solving. What we're going to do is we're going to approach it the same way. The number that we have outside parentheses is going to multiply to each number inside parentheses. So this is 4 times y squared plus, this is 4 times 8y plus, this is 4 times 2. So what we did was we took that 4, we multiplied it to y squared, we took the 4, multiplied it to 8, took the 4, and multiplied it by 2. Now we're actually going to see what that works. If I have y squared 4 times, I have 4 y squareds. If I have 4 times 8, well, 4 times 8 is 32 y's, and 4 times 2 gives me 8. So in this problem, we just simplified the problem. We cannot put these together, these y's, but we just simplified this problem, because what we're able to do is we're able to put 4 and y squared together. 4 times 8y, well, I have 8y 4 times, so I have 8y, 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 8y. Well, instead of writing it 4 times, all I can do is say, what's 4 times 8? That's 32. I have a total of 32 y's. 4 times 2, that's 8. The reason why we cannot put y squared and y together is they have different exponents. This has an exponent of 2, where this actually has an exponent of 1. It's a number all by itself. So something that has different exponents are not considered to be like terms. Only like terms can go together. So we need to make sure that when we're putting numbers together, they have the same variable and they have the same exponent. So this is simplest form because nothing can combine together, and that's our problem for this one. Let's go ahead and try some more problems. In this problem, I'd like you to maybe pause the video, see if you're catching on to this, see if you can do the distributive property and get the right answer to this one. So I'll give you about a second pause. Cool. Alright, and now we're going to go ahead and solve this. But let's see if you got the right answer that I got whenever I do distribution to this problem. Now remember, we do not change the order though. So I do 6 times x, that's 6x, 6 times 4, that's 24, and the sign that's in between just drops down. So my answer really is 6x minus 24. If you got that right answer, great. If you didn't, please ask a question and maybe I can help you understand how to get to that answer. Let's keep going, and we're almost done. Don't worry, I got you. Alright, for a challenge problem, one of my favorite ones. We're going to be doing distribution property, and this time it has 4 different numbers on the inside. I can tell it has 4 because they're separated by addition and subtraction signs inside the parentheses. So there's 1 number, 2 numbers, 3 numbers, 4 numbers. We're going to be multiplying it by 3, which means that we would technically see this problem 3 times. But instead of writing the problem 3 times, we're just going to do distribution property and get the right answer. So, if you feel like you can do it on your own, pause the video. I'm going to go ahead and solve it. But pause it, play it, and then see if you got the right answer. 3 times x to the 3rd power is 3x to the 3rd power. 3 times 2, that's 6, and then it's x to the 2nd power. 3 times, now here's where it gets tricky. 3 times a negative 5. That's a negative 15x, and 3 times 7, that's 21. So in this problem, you should have got 3x to the 3rd power plus 6x squared minus 15x plus 21. The one part that was tricky here is I have a positive times a negative 5. If I cover everything up, that looks like a negative 5. So that's a positive times a negative, which is a negative 15x. Now, a negative sign is the same as the subtraction sign if you use it correctly. So as long as we put things in the order that they were in, it still says the right answer as a problem. 3x to the third power plus 6x squared minus 15x plus 21. And again, that's still a negative 15x if I cover that up. So this is the answer I was looking for. If you got that answer, that's awesome. I feel like you're on the right track and you're ready to go. If you didn't get that answer, I really hope that you're ready to ask some questions and get those answered in the class tomorrow, okay? Let's try a few more and then let's call it a day. In this problem, we're actually not looking at distribution property in the same way that we were looking at distribution property. In this one, we're actually combining things that are like terms. 17a's and 21a's are like having the same label. So this is like 17 apples plus 21 apples. Now, we could actually do distribution property, but not actually give something to each one, but instead of give, we could actually take something from each one. We could take out something they both have, and that number could go on the outside, and what's left could stay on the inside. So if looking at both on these problems, they both have the letter A. So what we could do is we could take A out of the problem, because they both have it. So what we're really doing is we're dividing A out. So a number that we divide out goes on the outside of parentheses, and what we have left goes on the inside. So if I take A divided by A, that cancels out. A divided by A cancels out. So the A is the number that we just took out. Inside the problem, we'll still have 17 plus 21. Now, we all know that 17 plus 21 is 38. So what this really means is that we have A times 38. And A times 38 is 38A, because numbers always go in front of variables. If they're behind the variable, a lot of people think that they're exponents. So we always put the number right in front of the variable to the left of it. So this is what distribution property could do. We could take a number out as long as they both have it. In this case, they both had the letter A. So we took the A out of the problem. It went on the outside. And what we had left after we took A out stayed on the inside. We're able to add 17 and 21 because they're regular numbers and we know what those equal. 17 plus 21 is 38. We end up with 38A. Now what you can do is, as long as they have the same label, you can go ahead and put those together right from the beginning. If I had 17 apples and I had 21 apples, I have a total of 38 apples. So to me, a variable is like a label. In order for us to say that we have more of that label, they have to have the same label. So an apple is the same as an apple. But if that was a different letter, then they wouldn't be the same. And we couldn't put those together. So an example of that would be like this. If I had 17 apples and I tried to add 21 bananas to it, that doesn't mean that I have more apples. And that doesn't mean that I have more bananas. I cannot physically add apples and bananas together and get some type of apple or some type of banana. So what we do is we leave them separate because the labels are different. These are not like terms, where these are like terms. And then distribution property, the way it works is we can take out the thing that they have alike and put it on the outside. And what they have left, we can put that together and figure out what's left. You don't have to worry about this too much. I just want to make sure that you understand that in order to combine like terms, they have to be the same. And we have to have the same label to put them together. If they don't have the same label, we cannot put them together. And this is as simple as it gets. And what we're going to be doing over the next few problems is we're going to be practicing what things can go together and what things can't go together based on their like terms. So let's get practicing on those. So for this example, what we have is we have to simplify the problem. We have 12b to the second powers minus 8b to the second powers plus 6b. What you want to do is you want to say what doesn't look like the others. This 6b does not look like these other b's because these b's are to the exponent of 2. Since they both have the letter b and they both are to the second power, that means those are like terms. So what we can do is we can actually figure out what this equals because they're like terms. If I have 12b squareds and I take away 8b squareds, I still have 4b squareds left. So we're really just focusing on the numbers but keeping the label the same. 12b squareds minus 8b squareds gives me 4b squareds. Now, since this is different, we're just going to bring it down. And this would be our answer. It's 4b squared plus 6b. The only thing that we're able to combine is these two because they have the same exact exponent. Anything that has the same exponent and the same variable are like terms. We can put those together. This is completely different than those b's, so we cannot put this with it. So this is simplest form. Let's practice a few more and you're done for today. By now you're hopefully getting this, so maybe you could pause the video, see if you can figure out the answer to this. If I have 14x's and minus 9x's, what do I get left? If you got 5x's, you're absolutely right. So 14x's minus 9x's is 5x's, and you could put a label on it and say if I had 14 apples and I take away 9 apples, I end up with 5 apples left. So a variable is kind of like a label. They have to be the same in order to actually subtract or add. Multiplying doesn't really matter, or division doesn't matter. So make sure that whenever adding or subtracting, you have the same label in order to combine the like terms. Our job in this one is to simplify this problem. If you feel like you can do it on your own, go ahead, pause the video, do it on your own. I'm going to go ahead and go through this. And this, I see that this has 6n squared plus 7n's plus 8n's. What we want to do is identify the things that are the same. 7n's and 8n's both have an n, and both of those n's don't have an exponent, so they must be like the same. So what we could do is we could add 7n's plus 8n's, and we get a total of 15n's. Since this is different, I'm just going to go ahead and drop this down. So this problem really is 6n squared plus 15n. If you have any questions, please make sure you ask those questions. In our last example, what we're going to be doing is we're going to be doing this problem right here. It's example number 13. So that's quite a few examples that we've gone through today. Hopefully you found some of these examples are easy. It says use the expression 6 times the sum of x and y increased by the difference of 5x and y. And you could end up with some problems that look kind of like this when doing the state test and stuff like that. So I want to make sure that you're ready and you can actually solve them. 6 times the sum of x and y. Well, I know that I have multiplication, I have addition of x and y. Now, increased by is also addition. Then it says 4 times the difference, which means subtraction, x and y. So I have all these different things happening, and all I did was underline the small pieces that they gave me in the problem. So this right here should look like 6 times, sum means addition, and this addition is going to be x and y adding together. Increased by, that's a plus sign, 4 times, so I'm going to write 4 times the difference, that means subtraction, the subtraction of 5x and y. So this is kind of the things I'm doing, is I'm writing down what these phrases say. 6 times when I should have 6 and a time sign. The sum means I'm really adding, but now I'm looking at the word sum and it's telling me I'm adding x and y. So now I have x plus y. So that means I'm taking 6 and timesing it by x and y being added. So that would look like this. 6 times x and y being added. Because I'm adding it to the answer of addition. So I have to have the answer of addition before I multiply it by 6. Increased by, so I'm going to put the plus sign. 4 times, so I'm going to start with the 4. But it's 4 times the difference of 5x and y. So I'm going to take this 4 and it's going to multiply to the answer of subtraction. The answer of subtraction is between 5x and y. Well, I see that it says that I'm doing the difference of 5x and y. So this means that I'm multiplying by 5x minus y. So what we did was we wrote an algebraic expression for the verbal expression that we read. This is algebraic because we're including variables. Now what we're going to do is we're actually going to distribute and combine our like terms. This is the last thing that we're going to be doing. So we're going to do the distribution property. 6 times x, that's 6x. 6 times y, that's 6y's. Then we're going to do this. This is a positive 4. 4 times 5x, that's 20x. And 4 times, now, This is kind of tricky. It's 4 times a minus y. What you could do to make things easy so that way you know what you're multiplying to is anytime you have a variable by itself, put a number next to it. The number you can always put next to any variable that's by itself is you can always put a 1. So this is really 4 times a negative 1, which is a negative 4y. Now, what I like to do when combining like terms, whenever it's really long and written out and everything's kind of jumbled, is I actually like to cover up the pieces I don't need. So I'm going to start with the first part. This is really 6x plus 20x. Well, 6x plus 20x is 26x. Now, I don't need the 20x because I've already used it, so I'm going to read the next part. So I'm going to cover up 20x, and now it looks like it says 6y minus 4y. 6y's minus 4y's is 2y's, and that's a positive 2y's. So I'm going to write positive 2y's. This is the simplified form of this really long expression that we wrote earlier. That's it for today. Hopefully you have some questions. Hopefully I can answer those in class and we can practice and we can see where we're at and if we're understanding the distribution property. Make sure you're ready. Make sure you have your notes, and I'll see you tomorrow.